Hi, I'm Dr. Incognito. In this video, we're going to use the chain rule in some examples involving the logarithm function and the inverse tangent function. So first here we have the chain rule formula. The derivative of the composition f of g of x is equal to f prime of g of x times g prime of x. G of x I'm going to call the inside function, and f I'm going to call the outside function. So this is the derivative of the outside evaluated at the inside times the derivative of the inside, or for short, just the derivative of the outside times the derivative of the inside. So in the next few examples, we will need to know the derivative of the natural logarithm function. The derivative of natural log of x is 1 over x. And the derivative of the inverse tangent function, also sometimes written as arctangent. Inverse tangent, or the arctangent, has as its derivative 1 over 1 plus x squared. So I have an example here that we'll begin with, the derivative of the natural log of x to the fourth plus 2. In this example, we have a composition, f of g of x. The inside function, g of x, is x to the fourth plus 2, and the outside function, f, is the logarithm function. So I begin, I need the derivative of the logarithm function evaluated at the inside function x to the fourth plus 2. So the derivative of the log of x would be 1 over x. I need, here instead of 1 over x, I need f prime of g of x. So I need 1 over g of x. So 1 over the inside, 1 over x to the fourth plus 2. So again, the derivative of log x is 1 over x. That would be f prime of x. The formula calls for f prime of g of x. So in the place of x here, I want to put g of x, which in this problem is x to the fourth plus 2. So instead of 1 over x, I have 1 over x to the fourth plus 2. That's for this part, the first factor in the formula. The second factor, g prime of x, is the derivative of the inside function, which is 4x to the third. So we could write this as a single fraction, 4x to the third over x to the fourth plus 2. As another example, let's consider the log of the secant of x. This one has an interesting answer. The format is similar to the last problem. I want the derivative here, d over dx of the log of the secant of x. So the inside function in this example is secant of x instead of x to the fourth plus 2. And the outside function is the natural logarithm again. So we proceed just as in the last example. Instead of 1 over x, it's going to be 1 over secant of x, 1 over the inside. We don't want f prime of x, which would be 1 over x. We want f prime of the inside, f prime of g of x. So 1 over secant of x times the derivative of secant of x, which is secant of x times tangent of x. And then you see a nice simplification here. 1 over secant x times secant x is 1. So this is equal to tangent x. So a nice simple answer. For the next example, we will look at the logarithm of x to the fourth power. So our function is the logarithm of x to the fourth power. And just as a matter of notation, the logarithm of x to the fourth power, we put the exponent here as a superscript above the n, but it really means the logarithm of x quantity to the fourth power. And in this format, we can clearly see the inside function here is the log x. So that's different from the last two examples where the outside function was log x. Here the inside function is log x, and the outside function is the fourth power. So we don't typically use this notation. We use this to avoid the brackets, but the one with the brackets is a little bit clearer in terms of what's inside and what's outside. So logarithm of x to the fourth power, the log is inside, the fourth power is outside. So first we have to differentiate the fourth power function. So we bring down the 4 and make it a 3. And what goes inside is not x, but g of x, which is the inside, which is log x. So 4 times the log x cubed times the derivative of the inside, which is 1 over x. So in that example, we had the logarithm on the inside. So the derivative of the inside was 1 over x. The outside function was the fourth power function. So the derivative would be 4 log x to the third power. Okay, and one more example, this one involving the inverse tangent function. Let's suppose we want the derivative of the inverse tangent of x to the fourth power. So this is a composition. The fourth power function is inside of the inverse tangent function. So first we want the derivative of the outside, the inverse tangent function, evaluated at the inside, evaluated at x to the fourth. So instead of saying 1 over 1 plus x squared, I'm going to want 1 over 1 plus g of x squared. If this was f of x, then this would be f prime of x. In the formula, I don't want f prime of x, I want f prime of g of x. So I want f prime of x to the fourth. So in the place of this x here, I'm going to put x to the fourth. This is the derivative of the outside function with the inside function inside. So here's the inside function, and here it is still inside the derivative. G of x is inside of f, g of x is inside of f prime. This is f of g of x, this is f prime of g of x. And then times the derivative of x to the fourth, which is 4x cubed. And we could write this as 4x cubed over 1 plus x to the power. 4 times 2 is 8. So 4x cubed over 1 plus x to the 8th. Okay, so there's a handful of examples of the chain rule using the natural logarithm and the inverse tangent function. Thank you for watching.